So welcome everybody to the webinar. You are all math teachers, I assume, or somehow associated with math in schools. And many of you may be very new to our webinars because we don't often run webinars for math educators. So we're excited to have you with us and appreciate you spending the time. We know it's tough on school nights, and we hope that you find it time well spent. We're going to be showcasing resources from NOVA, in particular from the recent program called Zero to Infinity. NOVA is produced at GBH, which GBH is Boston's PBS station. And we are the producer of not only NOVA, but also Frontline, American Experience, Masterpiece, lots of programs for kids, etc. And in the education department, we research, develop, and we publish educational resources for the equitable learning and development of young people and adults. And the resources that we publish on this platform, PBS LearningMedia. I hope that some of you are familiar with it. If you aren't, please visit the site, pbslearningmedia.org. It is free. It has thousands of vetted resources that are ready for classroom use. We cover all subjects and grades pre-K to 12, but tonight we're going to be focusing on the math, some of the math resources that are on the site. Not all of them, but some of them. On PBS Learning Media, you will find lesson plans, short clips from programs, typically 3 to 5 minutes, interactive activities, PDF files, and interactive lessons, which is a particular type of resource, and also collections. And collections are curated groupings of resources that you find through one URL. PBS and GBH are partners in bringing you PBS Learning Media. And again, this is where you will find the resources that we're going to be showing you this evening. And so if you're not familiar with it, we encourage you to visit the site. You are going to get a document tomorrow, a resource document. Actually, the link of it is going to be posted in the chat tonight. But there's a resource document that has all of the links of the things that you're going to see tonight. That will come in a follow-up email tomorrow, along with the recording. We are recording, and also a link to the slide deck. And you'll also have that later on posted in the chat. All right, our presenters tonight, I am happy to be joined by my colleagues at GBH. Ralph Bouquet is the Director of Education and Outreach in the NOVA department, and also Sean Stevens, who is the Director of STEM Curriculum and Instruction in the Education department, where I am. And then we are very pleased to be joined by Cynthia Agruso, who some of you met at the very beginning for a little pre-activity. Cynthia has been teaching for over 25 years, most of the time as a middle school math teacher. She currently teaches 7th grade in a looping scenario, which her department or her team implemented, so that she will have the same students next year and she'll teach them in 8th grade. It's a very interesting cycle. Cynthia is also the department chair and the curriculum lead at her school, and she volunteers a lot for different advisory positions with the state, with the Department of Ed in Massachusetts. And we are very pleased that she is an educator ambassador with GBH Education, serving a 2-year term. She's at the end of her first year, and it's been a pleasure getting to know her and working with her. And then we have a very special guest, and that is Dr. Tim Chartier, who is an author and a professor and affiliated with both Davidson College and the National Museum of Mathematics. And Ralph will be introducing him in a bit, a little further, because he has quite a long list of accolades. Welcome, Tim. Thank you. So the agenda tonight, Ralph is going to start and introduce you to the resources, the classroom resources that are on PBS Learning Media that come from zero to infinity. And then Cynthia will come on and talk about how she sees using them in the classroom with some strategies and some other resources that she uses. And then Tim will do a presentation on using sports analytics in the classroom. And at the towards the end, Sean Stevens will come on and talk about other math resources on PBS Learning Media. And I'll have a couple of final remarks, and then we'll end with some questions if you have them. You are welcome to post questions in the chat. The presenters, when they're not speaking, will be attending the chat, and we'll do our best to get to your questions. Some of you submitted questions ahead of time, by the way, in the registration form. The presenters have seen them and have tried to work some of the responses into their presentations. All right, I'm going to turn things over to Ralph.
All right. Good evening, everyone. Thank you so much for joining us and being here with us today. My name is Ralph Bouquet. I'm the Director of Education and Outreach for NOVA. And in my role, I oversee the production of educational resources from NOVA's broadcast and digital content, as well as a wide range of our outreach and engagement activities. And so today, I'm really excited to talk to you all about one of our new shows this season, Zero to Infinity. And I think what's really special about this show is that it's a very sort of new type of show for us. We don't often have the opportunity to really get into doing documentaries around math, and it's really, really exciting that we really sort of tackled that and create some great resources to help math educators use this show in their classroom. And so the NOVA Education mission is essentially focused on curating multimedia STEM resources and events that leverage content from the documentary series NOVA. And our aim really is to empower educators, youth, and lifelong learners by fostering curiosity in the sciences and promoting inclusive science communication, as well as amplifying the next generation of leaders in STEM. And I really want to point out one of the details here around sort of inclusive science communication. I think this is something that really applies to this particular show, just because of the way in which it not only focuses on telling and explaining these concepts, but really going into the history of how many of these mathematical concepts came to be. And that's something that you don't often get the chance to really do in math courses, but we are really, really excited because this is a show that allows us to really engage deeply with this history and with a lot of the context around why these, how these sort of mathematical concepts came to be. So let's move on to the next slide. And now, where do you find these resources? And so one of the best places to start is, of course, in PBS Learning Media, where you find so many of educational materials from PBS brands. Our NOVA collection in particular is a very, very large collection that allows you to actually browse via different STEM branches and disciplines. So you can actually click on every single big topic, and then you'll find sort of the sort of subtopics that allow you
Is
to—
everybody frozen?
Oh, I think I'm okay.
Oh, okay, you froze for a minute. So
Oh, my apologies. But the STEM collection, this collection allows you to browse by subtopic. You can see sort of areas around our labs. You can see some of the collections we've created around STEM careers, as well as some of the special collections we've designated for some of our broadcast series. So on the next slide, we can take a look at the Zero to Infinity film, which is available to stream on our YouTube channel. So if you go to NOVA PBS on YouTube, you can find that collection there. It is also available to stream on the NOVA website. And so you can also find it there. It's about an hour long, around 52 minutes. And you'll find a lot of really, really great stories within that documentary. So please, again, we highly encourage you to check that out on either YouTube or also on the NOVA website. And so I thought it would be really helpful for y'all to just get a chance to see sort of what this documentary is all about. And so we're going to watch the prologue, the preview of Zero to Infinity, hosted by mathematician Talithia Williams. All right, let's take a look.
We live our lives surrounded by numbers.
Tipping the scales at a whopping 14 pounds.
The price, $400. But 145,000 new infections.
But they didn't all arrive at once. Why did it take so long?
Its utility in mathematics is undisputed.
For one number in particular,
It's more like a concept than a number.
to gain full numberhood.
I'd call it a very significant number.
What's so scary
You divide a number by it, you blow up.
about zero?
In science and mathematics, the simplest ideas end up the most influential, the most profound.
From zero, where do numbers lead? Can we follow them all the way to infinity?
Infinity and zero are two sides to the same coin.
Can one infinity be bigger than another?
How much there is to understand, that's where all the amazingness of infinity is.
What happens when mathematicians mix the clout of zero with the power of infinity?
It's all one big principle.
Nothing less than our modern world. Come join me, Talithia Williams, as we dance with two of the strangest beasts in all of mathematics. It's nothing and everything. Zero to infinity, right now, on Nova.
All right. So again, the film essentially investigates the concepts of zero and infinity and looks at the ways in which, first of all, that how they are relatively recent human inventions, but really helps to explain sort of how they revolutionized mathematics at different points throughout human history. And so it really is a globe-trotting adventure where the host, mathematician Talithia Williams, really talks to scholars, goes to really incredible locations and explore sort of the history of how these concepts came to be and their impact on mathematics. And so I think what's really interesting, again, is it's not just sort of an interrogation of these concepts, but really sort of allows you to understand sort of how they came to be and how history, how they have shaped mathematics over time and throughout different human cultures. And so on to the next slide, we can talk a little bit about the collection. And so our new collection that we just published a few weeks ago includes 4 resources that are taken from the film and includes several clips and excerpts that you can download and use in your lessons, along with support materials, some background readings, teaching tips, and some really great activity handouts to accompany these resources. And really, again, you'll see some examples of concepts that you'll find in geometry, in algebra, and in calculus that are all included in this collection. And so I'm just going to do a quick run through of some of those resources and what they are. So on to the next slide. One of the first resources is really a geometry themed resource looking at how to calculate the area of a circle using pizza slices. So really, I mean, this is a really great resource to help students really understand sort of how the formula for the area of a circle came to be. And I think this is really crucial because it helps students understand that these concepts are not just sort of arbitrary formulas that people just sort of pulled out of nowhere. There's actually a reason and a logic behind how these formulas came to be. Let's move on to the next resource, which is all about the history of the number systems. And I think this is really interesting because it really goes into the history of how our number systems came to be, looking at some of the ancient Persian mathematicians who really sort of worked together to create our number system, particularly the invention and the creation of the concept of zero. And so that's really highlighted here. So this is, again, really important for algebra, but also in helping to really help students understand number systems. It seems now very intuitive that, yes, we have the number zero, but you can also sort of think about the fact that like Roman numeral systems, for example, don't include zero. And so how does this invention, how does this idea of zero come to be? And how does it impact the way in which we look and conceptualize math? And then on the next resource, this is really a deep dive into the history of zero. And so it looks at sort of the different points in human history at which the concept of zero was used and was shared and propagated by these mathematicians. And again, really great resource. I think really provides a lot of historical context that often students don't really get to engage with when thinking about and talking about math. And then the last resource in the collection is around Zeno's paradoxes and limits in calculus. And again, this is definitely a bit of a higher order resource, but definitely I think helps them to understand the concept of infinity. And they use the metaphor or use the example of instantaneous velocity with to the host actually shooting a bow and arrow and talking about velocity and movement there. And so it's a really, again, interesting sort of thought experiment that really gets applied to a very fundamental idea and concept in calculus around limits. And so definitely, I think in our next session, Cynthia will actually go into a bit more detail as to how she uses these resources to really talk about these concepts. And so, yeah, so that is pretty much it for this collection, but we definitely highly encourage you to check it out. Again, it's free to access in the Nova collection. All of the resources and the video clips are downloadable, and they all come with great support materials that the GBH education team has put together. And so we really hope you enjoy it. Oh, and then, sorry, I had one more slide, forgot about this one. Additional resources, and so we'll make sure to post these as well in the resource guide, and I'll drop a couple of links to these. But we hosted a really great virtual field trip that actually included Dr. Tim Chartier from the National Museum of Mathematics to talk about zero to infinity. There's also a really great live stream conversation that we hosted with Talithia Williams, as well as two other mathematicians who appear in the documentary, talking about their experiences of math and their excitement around these concepts. And then there are a couple of articles that you can also check out that explain some of the concepts in the series. And so we'll make sure to drop those links to you in the chat, and you can also check them out in the resource guide as well. And now I will hand it off to Ms. Cynthia Agruso to talk about sort of how she uses and utilizes these resources in her classroom with her students.
Good afternoon, good evening, everybody, and thank you for joining us. Just a little background on me. I've been teaching for 25 years, and I've pretty much taught every grade up to 8th grade. And as Caroline mentioned, I do loop with my students, and it's a really excellent model in terms of having students knowing where they are and where you're going. However, both of my looping sessions have been interrupted by COVID. So this is my first one that hopefully goes through to the very end. I've taught 7th grade math, 8th grade math, algebra 1, and I'm currently teaching the illustrative math curriculum. We're in our 2nd year pilot. And I also teach adults in the evening for high school equivalency. I've taught like ELA, science, and all of that stuff. So, and I do a lot of state testing and curriculum with like looking at questions and data and reviewing curriculum. Also, I did drop this little link for the which one doesn't belong if you're interested. And this is the logo right here at the bottom. So if you need, if you want to get that, I can drop that link in the chat after. Next slide, please. So we're talking about the zero to infinity. When I took a look at this documentary, I was like, wow, there's lots of stuff. And of course, there's it goes from 6 to 12. So there were certain parts of it that resonated with me. Some of it was higher in the calculus field, which was not relevant for what I was teaching, what I'm teaching right now. However, there was one part that really stuck out for me was about circles. And it was kind of mind-blowing when I was watching it. I was like, oh my gosh, this is amazing. This is going to be fantastic for my students to really have a conceptual understanding of how you find the area of circles and circumference and all of that. We can go to the next slide. So the one that really stuck out for me was the calculating the area of a circle using pizza slices. And I immediately was like, what? I would love to do this in class. However, I'm not going to buy pizzas for everybody. But the materials over there on the right in the green and yellow arrows have some discussion questions for you to discuss with students. And then there are handouts for like problems that go along with a reflection from the video. And they are all shareable. Over on the left, I have a red circle, all shareable to Google Classroom. Very, very simple for you to hop in and go, oh, I like this. Put it in your Google Classroom if you have that. Or there's a link you can share also with students. And like I am going to say, like, I would never show the whole video all at once. I would probably stick with just showing the little segments that were pertinent, because I don't think a whole class just watching the video is going to give them, you want the little snippets. We're in that short video age where you can't show anything too long. All right, next slide, please. So these are the resources for the circle. So there are the discussion questions on the bottom that pops up on the screen when you hit it. You could like download them or copy them and put them on a document if you wanted. And you could tweak some of the questions. Like there's one on the bottom. It talks about how it's related to calculus. I just don't think my 7th graders would get that at this point. We're still working with trying to figure out what that formula is. And then there are the handout with the questions. There are different ways I would use that in class. I would obviously do them in groups. I think that's my first space I would go. And I might also take those questions and put stuff like a big piece of paper on the wall with the questions next to it, and vertical spacing where students are standing up around the room, and they're more likely to answer those questions because they're going to be looking around going, oh, that group is now answering them and they're answering them. So they're like, we better get something on this paper as opposed to having them on those flat surfaces. That's one new strategy I've learned that is proving to be getting people to do work when they're in groups and everybody is a little more participatory. Okay, next one, please. Here's a picture of the tweak on the pizza situation. So the pizza that I saw in the video, I was like, oh, I'm going to get a paper pizza. So I gave some students a paper pizza and we talked about cutting it up into the pieces and then starting to like, can we get it to be a rectangle? So I would do it as an opener just to like give it to them and see, can you do something with that? And then like, as you go through, I would go with start with my lesson for illustrative math and get in there and then squeeze the video in there and then have them go back and try that pizza activity. There's also lots of connections with the social studies, like the mentioning of those ancient math and those ancient civilizations, and some of the other pieces of the 0 to infinity. My unit 3, grade 7 IM curriculum definitely has this circle thing going on with the pizza. And when I watched the video and then I'm looking at my curriculum, I was like, whoa, this melts right into the curriculum for me. Next one, please. So here is a picture of the unit from illustrative math and the lesson that does the pizza and turning it in. And in the book, it has them making a circle and cutting it up. And I definitely feel like giving them a piece of it pre-cut. It kind of moves it along for them and will give them the opportunity to see what you're really getting at. And then when they see the video and the way it works out, it makes even more sense. Also on PBS LearningMedia, there is a whole section of illustrative math. It does not cover every unit because it's more like the power standards, but they definitely have a bunch of resources in there that support the illustrative math curriculum. Next slide. And the other one that was of great interest to me, but I can't do it right now, is the 0 to infinity. I'm super excited about doing that when we start hitting integers and giving students a background of where the numbers come from. Also, I was very attentive. It was noticeable to me, the diversity that was put into this video. I know with teaching adults at night and just giving kids videos, it is very difficult to find people of color in a video, delivering math, women. And I was super happy to see that this video had those pieces that I'm looking for to bring into my classroom for my students. Next slide. I have some other favorites that I have found on PBS Media. I was going to share those. One is called Scale City, and it's an entire collection on looking at scaling anything. Like they go to a museum and talk about like the Louisville Slugger Museum creating a giant bat and how they create that. I have stuff on recipes, scaling recipes up. Super, and it's great enrichment. I often sometimes leave it for if I'm going to be out, and it's an excellent resource. It has the paper that goes with it. The students watch the video. They have something that they might have to hand in at the end. It's a great resource, and it's good for looping and spiraling back to make sure students are still keeping what we've learned in the past. And then there was one more. Yep. And then this one I love as well, because as you all know, you probably get the same question. When are we going to use this? Why do we need this? And I found this real life math, and it has all kinds of careers that use math. So like there's physical trainers, there's cooks, there's astrophysicists, there's pharmacists, and it has an activity that goes with it. Sometimes it's more like participatory in the class. Sometimes it might be just a worksheet that goes along, like a recipe, and how would you double it, triple it with the ingredients. But that's a great enrichment piece that I use as well. And I found them to be very routine, that I've been putting them in my class. But that's another great resource that I wanted to share. And so that leaves me to send it back to Ralph so we get to our next part. Thank you very much.
Great. Thank you so much, Cynthia. All right. So now we're going to transition to our special guest presentation. And I'm really excited about this as a big sports fan. It is really exciting to get to talk and to learn more about sports analytics. And so I'm really excited to introduce Dr. Tim Chartier, who is the 2022-2023 Distinguished Visiting Professor for the Public Dissemination of Mathematics at the National Museum of Mathematics in New York City, also known as MoMath. If you are in New York, this is a really incredible place to visit. He's also the Joseph R. Morton Professor of Mathematics and Computer Science at Davidson College. Dr. Chartier is a professionally trained mime. He's performed throughout the United States and in Panama, France, Japan, South Korea, and the Netherlands. And I did want to mention and plug again our virtual field trip if you didn't get to see it earlier. Dr. Tim Chartier did a really incredible mime performance around the concept of infinity, which sounds very complicated, but when you see it, you'll completely understand what I'm talking about. He trained at Le Centre de Silence Mime School and in masterclasses of world-renowned mime artist Marcel Marceau. Dr. Chartier has also published books and numerous articles on data analytics, and his specialty is sports analytics. And so he's worked with professional teams in the NBA and NFL, as well as working with the U.S. Olympic and Paralympic committees. And Dr. Chartier is also regularly used as an expert in national media outlets. So you might have seen him in the New York Times, CBS Evening News, and also ESPN for sports analytics. And so obviously, this is an area that has gained tremendous momentum as one of the most dynamic fields. And so we're really excited today to welcome Dr. Tim Chartier. All right, hand it over to you.
Great. Thank you, Ralph, and welcome, everyone. I'm so excited to work with you. It's just wonderful to talk to teachers that are in the classroom. And I teach at the college level, and the work that you do springboards students that I get to work with. And now when I'm spending my year at MoMath, I get to see both teachers and students in the museum. So today we're going to talk about how to get in the game, which is basically how to do sports with math, which means that students who like sports will have a reason to do the math, which can be helpful for the why do I do this question, and it can help the other way around. So you can, and people who like both. So it really helps in all of those directions. One of the nice things for me is that this year that I'm spending at MoMath, when I walk through the pie-handled door, as you see in the upper right, There are many exhibits that deal with physical activity. In fact, the entire museum is basically an immersive experience. On the slide, you see that you could act like you're in the Tour de France, but rather than having a circular wheel, you have a square wheel. And rather than a flat track, it looks like a bumpy track, but it turns out it's not bumpy precisely when you have square wheels. Well, today I want to talk about sports analytics, and Ralph gave my background, but I want to talk a little bit about my work with students at Davidson, because that really generates my connection to both using it in the classroom and out of the classroom. In 2013, I had 3 students walk in my office and ask if we could create analytics for the men's basketball team. Now that's a tall order, because this is the same team that Stephen Curry came out of in college, a very successful team. I told them that I was willing to help them develop analytics, but I couldn't guarantee that the team would find them helpful. They did, and that group began with 3 students and grew to be 100. Well, one of the founding students is now at the Chicago Bulls, continuing to do analytics for them. One of our alums went and did analytics for the Jets. Another one in a summer internship worked with the WNBA, which is the Chicago Sky logo that you see on the slide. And then, as mentioned, we've done projects for national media. All of that stemmed out of working with college coaches, where we worked originally in men's basketball, then grew to women's basketball, and we now do men and women's soccer, baseball, volleyball, football, lacrosse, a little bit of field hockey, and a little bit of swimming. So you can ask about some of those later if that's interesting, because you can do out-of-class activities to support coaching staff as well. Well, one way to do math in the classroom is just to show a field or a court and say, what mathematical things do you notice here? Maybe you want to be more specific and say, what mathematical shapes do you see here? Now at the header, I say squares and rectangles. I wouldn't even put that on the slide, because it's very likely people will see parts of circles or whole circles. And then, as we saw in our opening activity before we started, there'll be many answers that you haven't thought of, which is part of the delight of asking open-ended questions. Well, I want to focus particularly on the bottom of the page, which is home plate. Home plate is given the dimensions that we see on the slide. And in the Major League Baseball rule book, it says that home plate extends those lines. And you will often see that little corner at the bottom denoting that it's a right angle. Okay, well, easy enough. So it's a right triangle with the sides of 12, 12, and 17. The problem is Pythagoras would have something to say about that, because we have the formula due to Pythagoras, or at least bearing that name, because it does come from several cultures, is that you have 12 squared plus 12 squared equals 17 squared. Well, that means 144 plus 144, which equals 288, is going to equal 17 times 17, which is 289. Well, the only way to kind of have that happen, if you think of it as subtraction, is that 2 things are equal if they subtract and both in the sum or the difference is 0. Well, unless 0 equals 1, this is not a right triangle, which can be really fun for Major League Baseball and baseball fans, because you can kind of, if you want to, say that every baseball field has a math error on it, or at least the way we think about it doesn't align with the actual geometric properties. This idea of using kind of shapes in ways that are either surprising is also seen in mathematics in what are called dissection puzzles. We'll get back to this chocolate bar in a moment, but I want to show you another one. This one will bring us to where I'm sitting right now, which is Manhattan, New York City. And a little bit behind my building, if I were facing the other way, my window would be looking at the Empire State Building. So sometimes even counting can be unintuitive. As Ralph was mentioning, even the number 0 originally was unintuitive because you don't have anything. So how do you even have a number? There isn't anything. Well, how many Empire State Buildings do you count on the slide? Okay, now you may not count real quick, and that's entirely fine. So I'm talking a little bit, but now I'm going to give you the number even if you're still counting, and you should count 14. Now this is a physical puzzle. There are 2 pieces on top that can flip their place, and there is no PowerPoint kind of kind of tomfoolery going on here. It's an actual physical puzzle. And when you switch the pieces, easy enough. Well, let's count again, just to count. How many do we count now? Well, now we have 5 sets of 3. Wait, 5 sets of 3 is 15. Let's go back to the original one. So we have 3, 3, 3, 3, and then 2. So that's 14. We swap and we have 15. Okay, well, let me look at the 2 puzzles side by side, or up, or side by side, but vertically, if you will, side by side. So I'll give you just a moment to look at that. You can spend quite a bit of time with students looking at that and stating the things that they see. They'll see many different things. But what I like to show now is that we may see things, but exactly why is it working? I never knew when I first saw this until I saw the following. So rather than taking the ordering that we have on the top slide for the 14, we're going to jumble them up and instead show them in this ordering, which is actually the way that they're made. Then the second ordering with 15 is equivalent or the same as just doing that shift. And that gives you 15. Well, the original puzzle that we had here is quite amazing, almost magical. This, on the other hand, is wildly not. But it also gives a very important lesson of mathematics. And that's that sometimes it can almost seem like someone who's getting the answer is being magical. I don't know how you're doing that. And often in math, when we organize things in a particular way, which we have to see and learn how to do, suddenly the magical can become logical. If you're interested in this, well, let's watch the puzzle one more time now that we know how it works. So we'll swap the 2. There you go. If you're looking for this actual puzzle in the email that you'll get tomorrow, you'll actually have a link to The Guardian. The Guardian, I created this puzzle for The Guardian for an April Fool's issue in which the title was The Empire State Building Vanishes, and that's where you can find it. There's also another one which actually does use digital, it stretches the chocolate bar a little bit throughout the animation, is my favorite chocolate bar because it's infinite. So you never get to 0, which is great. Well, my wife and I took a particular frame of this picture and then made it into a physical chocolate bar, which you see in the upper right. This is us in Japan, where we performed in the mime show that Ralph mentioned to a sold-out audience at the Panasonic Center in Tokyo. At the end of the show, they can come up and ask to see various things. And the children entirely wanted to see the chocolate bar. So that's what they're doing. They rushed the stage, and Tanya must have spent 20 minutes. They didn't want to know how it worked. They just wanted to keep watching it. If you come to the Museum of Math, there's a version of this downstairs where rather than having the 2 pieces swap, you turn an outer circle. And if the number of red monkeys goes up, the number of blue monkeys goes down, and the other way around, which is a nice version of it. Okay, let's get back to sports. So you're going to get to play Stephen Curry. This is a very nice example of a way to come at probability as well as other topics that are covered in secondary school. So we're going to look at the 2013-14 season when Stephen was shooting 45.3% from behind the three-point line. You're going to get to shoot better than Stephen Curry and shoot at 50%. This is the way it works, is that rather than having you flip a coin, I've already pre-flipped a coin. And you will guess heads or tails. If you guess it correctly, you make a shot. If you don't guess correctly, then you miss the shot. So you need to make a guess, and then you need to keep track of how many shots you make. Okay, so we're going to try it this time just to see if we have any questions. And at the end, if you do, we'll put them in the chat, because the next one we can't back up. So we're going to do it one more time after this. Okay, so make your guess, heads or tails. It's tails, so if you guessed tails, you made the shot. Guess again, guess again, guess again, and guess again. And that'll be the pace that we'll have on the next slide. So you might have gotten 3 or more out of 5. There's a good chance that quite a few of you actually got 3 or more out of 5. So if you did, Good, that's good to have. And it turns out if you are teaching at certain levels, you might even do this type of problem, which is called a Bernoulli trial, and you can get its 31%. There's another way to do it, which we'll talk about in a minute, but let's first do our larger question where we compete against Stefan. In 2014, in February, Stefan made 11 out of 13 three-pointers in Madison Square Garden. Let's see if you, shooting better than Stefan, can meet or beat what he did. Okay, so here we go. Make your guess, heads or tails. Guess again, guess again, guess again, and again, and again. Make a guess, 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 and make a guess. There you go. All right, can you put in the chat if you happen to get 11 or more? Did anyone pull it off? I think we have 53 Zoom accounts here. So did anybody pull it off? We have a quiet chat. And the reason for that is because it turns out you have just over 1%. So this works where you actually see it's achievable when you have 100 or 200 or 300 kids. They have to be paying attention though. So sometimes you pick up that people probably didn't pay attention. I did this in Millersville, Pennsylvania, to a group of about 400 secondary kids, and they came in and the students were trying this. And at the end, I said, how many got 11 or more out of 13? There were 300. So there should be between 3, 4, or 5. And about 40 hands went up. I don't know if that's because they had a question, they were excited, or they just hadn't quite been counting the whole time, but it was kind of funny to see. So this is a nice way to bring this into the classroom because it also opens up another way that you can compute probabilities, and that's through approximation. Now, we had a small number of people trying this, but we could do it again and again. At one time, I was called periodically by ESPN to help with the show Sports Science, and they often were asking me, Tim, we need your help with a probability. They were hard probabilities because in most cases, that meant that their staff was stuck on it. So what I often did when the question was a probability question is exactly what you just saw, except I used a computer. I would ask a computer if I was actually modeling exactly Stephen Curry, I would say, pick a number between, for instance, 0 and 100. If the number was less than 43.5, I think was what we had for Stephen, then he made the shot. If it's greater, he missed. I do it 13 times. Did I get 11 or more out of 13? If I did, I keep track of it. If I didn't, I say, that's fine. I do that 10,000 times. And then I see how many times did it happen. And it's a way to approximate a probability. And if you computer code, they tend to be short programs and they can be done quite quickly. You can also do this, for instance, in Excel. You might not do it 10,000 times, but you can still do it like 500 or things like that using a spreadsheet. One thing that's interesting is that if you like this type of idea of using dice and coins to be a random number generator, which is what I was doing with you, in order to approximate probabilities and get a sense of sports analytics, you can look at my book that came out in September called Get in the Game. It's very much geared particularly to secondary level, although it does work younger. And part of that came because of the fact that I first did that content at a Family Friday at the Museum of Math quite a few years ago. And that's where I began to work on the content of that book. But for you, another thing for you to be aware of is you may want to look at the Family Friday content of MoMath to see if you can find some content that can work for your classroom as well, because it's really for the whole family, not just for the secondary and up part of the family. Okay, now let's talk about getting data. So if you don't have data, how do you get it? Well, one way is to record it yourself. So this URL will be one that may appear in the chat. It will appear in the handout that you have. It'll also appear on the next few slides. So you could watch a game and click where the shots are occurring, and you can keep track of whether a shot was made or missed. To get a handle on what you can then do with it is you can ask for percentages or fractions or whatever, or just how many occurred in different parts of the court. You can even ask students to come up with their own regions of a court. Well, this is the region that a Davidson College student and I looked at, where in particular, when you look at the green and the yellow area, that boundary is the 3-point line. So any shot made in the yellow or orange area is a 3-point shot. In particular, that orange area is really far from the basket. Those are where we tend to think, I don't know if people really shot from there, if you're my age, back in the 90s or the 80s. Well, if we look back to Michael Jordan in the 1997-98 season, these are the percentage of time that they shot from those various regions in the playoffs. Well, if you go to a more modern team like the 2017-2018 Golden State Warriors, look at how different those numbers are. Well, the next slide shows what you can do if you're actually counting. Well, how many shots did they take and how many did they make? Well, if we look only at the orange area, the Bulls only took 12 shots from way out beyond the 3-point line, maybe at the end of quarters or the half, and they didn't make any of them. Whereas the Golden State Warriors took 52 and made 22. So when this helps confirm that we really are seeing further shots, and you can do it for other teams that do not have Stephen Curry and see very similar behavior there too. Okay, one more thing. So for the last few minutes, I want to show you my March Madness work. Here I'm working with 600 kids that came to Davidson College, and I taught them the math behind brackets. Very quickly with March Madness on Selection Sunday, we know which teams will play which. So here you see Gonzaga playing Georgia State and Boise State playing Memphis State. Your job is to predict who will win. Well, how do you do that? Well, in the work that I do, I work with ranking. In particular, I decide who's number one. Why? Because that helps me determine who will win in a math-based bracket, where number one, for instance, would beat number 5. So a better ranked team wins. The nice thing is you get to make your own bracket, your very own math-based bracket by making choices. The first choice you make is actually between math algorithms. You use scores or you don't use scores. The two methods are named after the creators, which isn't always helpful. There's the Colley and the Massey. If you look down at the writing, Colley is the one that only uses wins and losses, and Massey keeps track of the scores. If we have more time for Q&A, I can talk about why you would use each, but you usually use both anyway and see which one seems to work. Then this might be one of the few times it's nice to ask, what's your ideal weight? What this is doing is this is the one most often used by students, where I simply say, how many pieces do you want the season broken into? Here it's 2. In the first half of the season, the games are worth half a game. So you would get half a win and I would get half a loss if we played. And in the second half, they're worth 1 win. That's saying that the second half of the season, I believe, is more predictive of March Madness play. So how many pieces do you want that broken into? And you put that into the code. You have 4 choices for weighting. Uniform weight says I'm not going to do that at all. Log weight is a log function if you teach those. Linear weight I'll talk about in a moment. And then intervals is the one we just did. Linear weight does not have the y-intercept. It does, it's 0, but it's y equal mx. Generally, it's not a very good ranking method. The reason it's here is because middle school teachers around the country use this at March Madness time to actually motivate slope. And there was a high school student who actually produced a bracket who beat over 99.9% of 15 million brackets using linear weight. So this is the site you get. You get to pick your year, you can have your interval, and the last little piece here is you decide how much a home, away, and neutral game are worth. In the resources you get tomorrow, there'll be a video that will go through more detail of that. But at the end of this, it's your turn, where you just go to marchmadness.davidson.edu. In early March, I'll start giving data. If you're ready to do this in your classroom in February and you don't see 2023 data, just email me and I'll put it up on the site and you'll be ready to go. So my last thing is, why actually use math in sports? Why do it? Well, one of the things is when I asked in the beginning, what shapes do you see? Or at the end, when I say, what weights would you use? You have to decide. And I believe that sports analytics is a place where people can have insights. In fact, I've seen high school and middle school students come up with research insights. But the biggest thing is when you have the insight, having the courage to take your own thoughts seriously, which is what we're all working for in our classrooms. And we can do that with math and sports or using the Nova resources of 0 to infinity. Thank you. And I turn it over to Sean.
Thanks, Tim. That was awesome. I can't wait to go and check out some of these sites after this is over. And I'll definitely be paying attention to March Madness next March. So I'm going to just keep going and on this theme of making math meaningful for students, and maybe give you some ideas how you can use some Nova resources to do that. Next slide, please. First of all, there are a lot of ways math links to daily life. I think pretty commonly it's known about the Fibonacci sequence, and you can find it in nature in the number of petals flowers have, the arrangement of seeds in sunflowers. But pi is actually all over the place in nature as well, and not always in circles. The thing that I found out was in meandering river, distance of the meandering river divided by the distance from beginning to end as the crow flies, turns out to be on average about pi, which is pretty amazing. Next slide, please. Also, math and physics really relate a lot to music. In this particular resource, they're looking at the length of a string and the frequency it makes, and the sound it makes, and how the different ratios are more or less pleasing to the ear. So the most pleasing ones supposedly are octave, fifth, and a fourth. Next, please. And then, of course, there's a lot of math involved in keeping all of our digital data safe in encryption codes and such. Next slide, please. Probability plays a big role in search and rescue missions, not just in predicting where to look, but also in the search patterns that will most likely lead to success. Next, please. And then at this time of year, especially, you see delivery drivers out everywhere delivering packages. And every day they need to map out what the most efficient route is for those deliveries. So what they actually do is they're estimating solutions for the traveling salesman problem in order to map those routes. Next slide, please. Math also can play a role in helping to solve some societal issues. Most recently, they've been involving mathematicians that specialize in geometry to see if we can develop some objective measures to determine what is gerrymandering and what isn't. We can all look at shapes and be suspicious, but it would be nice to have that objective measure. So they're investigating things like curvature, which is basically the bendiness of shapes. So when you see those large populous areas connected by thin bits, like how thin the bit is, will determine how bendy it is. And so they're working to see if they can figure out some measure of gerrymandering. Next slide, please. And there are also just resources that you can use to bring a little joy to math. In this case, zombies in calculus. Zombies can actually be models for vectors because they move in straight lines towards their prey. And so here they have a resource that illustrates what tangent vectors are and how they show its movement at a particular instance on a graph. Next, please. And then also on the zombie theme, can use it as an illustration for why derivatives are useful and when and how we can use them to describe rates of change. While students might not be familiar or really have thought much about the zombie human predator-prey relationship, they will be familiar with this wolf-deer relationship from science. And so this is a really simple dynamic system that they can use math to model. Next, please. And finally, there's Nova Financial Lab. This is a series of games that students can use to model financial decisions and growth over time. You can do all of them, and that would take a few class periods, or you could just choose to do just one, whatever fits in your curriculum. This resource focuses on helping students learn how to achieve financial well-being. And so it's exploring how to, or when or why you want to pay off credit card debt or your car loan, which should come first, why you might not want to take on debt, and how you want to save and how that can pay, and how those decisions can have a big effect 1, 5, 10 years down the line. In addition to all these math concepts, there's also the psychological concepts of biases you may have, types of things that lead us to make smart and maybe not so smart decisions about spending money, which cumulatively could have a big effect over time. So all of that kind of stuff is modeled in this financial lab. And so now I'm going to turn it over to Carolyn to close us out.
Great. Thank you, Sean, and thank you, Tim and Cynthia and Ralph. We're always curious about what kind of sticks in your mind as we wind down webinars. So please feel free to put in the chat any reactions that you have to what you've seen so far. Also, of course, post any questions. After I just have a couple of closing remarks, we'll open it up to the presenters and to respond to any of your questions. So the resources that we have shown you tonight, that Ralph, Cynthia, and Sean showed you, and those final resources that Sean was talking about, gerrymandering, etc., are all on pbslearningmedia.org. Again, it is a free site. You can go to the site and you can search by subject up in the header right here, or you can put a topic or just put Nova in the search bar right here, and you'll go to the Nova collection. But there's lots more related to math. As you saw, Cynthia mentioned a couple of them, real life math and also Scale City, and you're going to see some more. We encourage you to sign into the site. You are welcome to browse without signing in, but signing in takes about 30 seconds, and then you're able to fully use the site. You can download resources, save them to folders, share them through Google Classroom or other platforms, and really make full use of the site. So these are just some banners of the collections that you will find. You can search by collection on the site. Let me go back here for a second. After you do your initial search, let's say I clicked on subjects and I come up with science, ELA, social studies, etc. You can then further filter your search by type of resource that you're looking for. So it could be a video clip, it could be an interactive, it could be a lesson plan, etc. But collections is one of those choices, a choice of a resource type. And I encourage you to start there if you're new to the site, because then you go to a collection like Nova, and then you have this whole myriad of resources in one search result, and searching and looking at the Nova page and going by subtopic, etc. So it's a good way to get started. Math at the Core is a collection of resources that are coming from many different sources. Nova may be one of them, but they're also coming from PBS partner stations around the country, and it is designed for middle school. Then here are 4 other types of examples of collections that are from Nova. Misinformation Nation is relatively new. I know that it's one of Ralph's favorites, and we have done other webinars using Nova resources, and I'll make sure you get the recordings of the recording links to those in that follow-up email. All of our webinars are recorded, and the recordings are all available on the GBH Education YouTube channel. So we strive to do better each time we do a webinar, and we hope that you give us some feedback. You're welcome to put things in the chat right now if you'd like. We also have a survey that our research department handles, and after completing the survey, you can download a certificate of attendance if you would like, if that would help you towards your PDPs. So the link to this survey is here. It's also in the chat. I posted a little bit earlier, and it will also be on the resource document that you'll get tomorrow. But if you're going to do the survey, you might as well do it really soon while things are fresh in your mind. So again, here are the links that I think I posted in the chat earlier. We do share a public version of our slides. The resource document is there. Tim has generously shared the links to all of the resources that he referenced. We also put in links to his books. All the resources that you saw from Sean and Cynthia and Ralph are here in this document, plus a few more. And then we encourage you, if you're not already on our mailing list, to sign up for the education newsletter so that you make sure you don't miss any of our events or new resources that are posted and published on PBS Learning Media. You are welcome to email me with any questions or comments you have. I will get you to the right people if I can't respond. And I'm going to stop sharing now and invite the presenters back on camera. And we can see if there are questions in the chat that you noticed, or if anyone has any further comments that we would like to make. Tim, do you have anything that you noticed in the chat, or something that you feel that you wanted to add? No? Okay.
I did have something I occurred to me I didn't say, is that on those dissection puzzles, one of the biggest points I make is that's why you show your work. And I do that very often at the beginning of the term, and it really helps with that discussion, because just because you think you see it doesn't mean it's what's really going on. And that's why work is so important.
Carolyn, somebody asked if you're going to be running this topic again.
Sports analytics or Nova resources. I'm not sure what this is the third webinar we've done this year showcasing Nova resources, because we love Nova so much. And I'm sure we'll be doing more of that. Whether we can do more with sports analytics or involving content experts like Dr. Chartier, let me know that that's what you want, and we'll do our best.
Nova resources, they said. More Nova resources.
Great. All right. Nova resources. The collection on PBS Learning Media is vast and ever growing. And in fact, Sean, do you have any, I don't want to put you on the spot, but is there anything that you know that's coming up soon, or something that you want to mention is coming? Or maybe Ralph has something that's coming from Nova to share with people?
Let's see. Well, I mean, there's a lot of fun stuff coming out, but not always a lot about math, because Nova is more on the science side of things. But upcoming, though, we do have something coming out on cryptocurrency and Bitcoin and what all that is, and also a couple of resources on from the episode, the computers versus crime. And so there's some ethical computer science, algorithm bias type resources coming out, which are math related, but more computer on the computer science. But we do have a lot of resources that are, even though they're science, they're good examples of math. Like one of the Misinformation Nation resources I put in there that is a really nice illustration of exponential growth and how it is going to increase so much faster than something that's growing linearly.
Yeah, and I will add, I know Sean mentioned this, but did really just do another plug for the financial lab. I think it's a really great resource just because not only does it really go into sort of basic financial literacy principles, but it also does a really good work around like behavioral economics and helping students understand sort of the decisions and the human biases that impact decision making around finances, while also teaching them like some really core principles around how credit works, how interest works, and sort of that interest accrual over time, and why it's important to understand these topics. Obviously, with so many of the conversations happening, in the news around, student loan debt, and I think it's a really great way to tie in those concepts and to provide some very clear sort of explanations for why these concepts are so important and why there's so much conversation around these particular issues. But highly recommend that you all check that out, because it really is, in addition to sort of the core math concepts, I think it just really helps to fill a need around financial literacy and really how to improve sort of our decision making around our finances, which is something that we should all learn in school at some point. But yeah, highly recommend checking out that resource as well.
And I see the question regarding resources being open. Yes, you are welcome to the PBS Learning Media website. First of all, it's free. Everything is free. And you are welcome to download resources, embed them into your instructional materials. You can share links. Downloading, we strive to make as much available for download as possible. Sometimes there are rights issues that we're not able to do that, but the majority of resources, videos that you can download. And so we encourage you to sign into the site so that downloading is permitted, along with sharing things through various platform services like Google Classroom, Schoology, Canvas, etc.
But I would be remiss without saying they are not open source resources. So you can't use them to make money or to distribute widely, but you can definitely use it for your download and use them for your own use or share it with your colleagues.
Yes, we don't want you to sell them. Yes, good point. Yes. Okay. All right. Any final thoughts or questions? Otherwise, I think we're going to wind down. I hope that this has been helpful for the teachers. Thanks again to Tim. It was fun to get to know you. This is a whole new area of expertise for me, and it was I am a big basketball fan though, so it was cool for me to be a part of that. And Cynthia, our educator ambassador and teacher, thank you very much. And my colleagues, Sean and Ralph, father of a brand new baby, and we haven't heard the baby talk this recently, Ralph. All right, good night,
I could have sworn
everybody.
he was in the background and it was screaming, and I could have sworn that audio was going through, but I'm happy to hear that you all did not hear that.
It was good. All right, you're welcome to sign off, and thank you very much. I'll keep the chat open just for another couple of minutes and wish you well, and we'll be in touch. Thank you. Good night, everybody.